Hi friends. In this lecture, I am going to discuss problems. Let us see first one. See the question given. A charged particle of mass m and charge q is allowed to enter a region of space in which uniform magnetic and electric field are present. The subsequent motion of the particle in the region depends on the initial velocity and directions of the fields. See the first question, that electric field is not present, only magnetic field. Direction is along positive z-axis, and this is now velocity. Then the path of the particle is. Let us see how to start. Right, first write down the given data. No electric field. It is only magnetic field. See what is when magnetic field is. So coming to magnetic field, direction is given k cap. V bar equal to B naught k cap. And coming to velocity, V bar equal to V naught I cap plus V naught J cap. Okay. And you can see here, if you want to decide what is a path followed, we have to focus what is angle between B bar and V bar. Okay. So we have learned that if angle theta equal to 0 or 180, it is a straight line. Okay. If theta equal to 90, then path is circular. Right. Now you can see velocity is confined to xy plane. It is V naught I cap plus V naught J cap. So velocity is in xy plane. Coming to magnetic field, it is along the axis. Means normal to this velocity. That means between these two vectors, angle is 90. Therefore, path will be circle. So now see options. Given option A helical, that is not correct, and B also not correct. Now we have to focus what is the radius of the circle and in which plane. You can see radius r equal to, it is mv by bq. And see what is the speed. Speed is now root 2 v naught. See modulus of this square root of v naught square plus v naught square. It is root 2 v naught. So m into root 2 v naught upon vq. That is now radius. And that you can see in option C and option D both. So now we have to focus this circle. Is it confined to xy plane or xz plane? Okay. Let us see how to decide that. So you can see here. Velocity is now, suppose this is xy plane. Velocity is now like this, making angle 45 with x-axis, or you can say 45 with y-axis. Okay. Velocity given like this. Now see direction of force. F bar equal to Q into V bar cross B bar. Okay. So Q into V bar. V naught I cap plus V naught J cap. So I cap plus J cap cross B bar B naught K cap. I am taking here outside V naught. Okay. Now see what we get. So we can take Q V naught B naught outside. Remaining is now I cap cross K cap. That is minus J cap. See once I cap cross K cap. That is minus J cap. Next J cap cross K cap. That is I cap. So from this we can say in which direction force is acting, right? So here positive X component, negative Y component. That means force acts now like this, right? It has a component along positive X axis and negative Y axis. That is what we can see here, minus J cap plus I cap. That means path will be circle, which is confined to XY plane. It will be like this. Okay. So it is a confined to XY plane, right? Let's see next one. B bar B naught K cap, E bar E naught K cap, V bar V naught I cap. Then the path of the particle is. So see how to decide this. Given both the fields, so it is given B bar, it is B naught K cap, and electric field, it is E naught K cap. So both the fields are parallel. So both the fields are parallel. And coming to velocity, it is given V naught I cap. So now we have to focus what is a path followed by the particle. Now focus here only because of magnetic field. Okay. For the time being, focus only magnetic field. You can see between these two angle is 90 because this is I cap and this is K cap. So angle 90 means path will be circle, right? Path is circle. And you can see here direction of force. Direction of force will be, see cross check here, F bar equal to Q into V bar cross B bar. V naught I cap cross V naught K cap. So it is a Q V naught B naught I cap cross K cap. It is minus J cap, right? That means see what happens. This is now X, Y plane. And we can see velocity given along y-axis. Sorry, given along x-axis. I cap, okay, along x-axis. Force is now along negative y-axis. So force is now in this way. That means the path will be like this. It is now circle. And motion confined to fourth and third quadrants. Okay. So this is motion only because of magnetic field. And we can see along the magnetic field, there is no velocity component. Okay. But because of electric field, now its velocity component along z-axis will increase from 0. That means it is going to follow helical path, helical path with increasing pitch. The reason is that along the magnetic field, because of electric field, velocity component along the field increases. Since velocity component is increasing, its pitch will increase. That's why it is helical path with non-uniform pitch. Or you can say it is a helical path with increasing pitch because its velocity along the field keep on increases. Or you can say velocity component along the field is keep on increasing. That's why pitch keep on increases. It is now helical path with increasing pitch. Okay. Now see options. So speed of the particle increases in the subsequent motion. So because of electric field, speed will increase. Okay, that is clear. Next, the path of the particle is a helix with non-uniform pitch. So we have discussed that it is an increasing pitch. Means it is non-uniform pitch. Right? It is a cycloid. It is not correct. So option A, B and C. So these three are correct. Okay. Let us see next one. So coming to the previous question and this question, the only change is velocity is having one more component. Okay. Then see where change comes. Because of this, already we have seen it is a helical path with increasing pitch. Now here also same thing. It is a helical path with increasing pitch. But what happens is initially there is a jet component for velocity. That is the only change. Okay. So a helix with increasing pitch and axis parallel to z axis. Already we have learned that axis of the helix will be parallel to B bar. So B bar is now along z axis. That's why axis is parallel to z axis. Okay. Next, helix with decreasing pitch. If charge is negative up to some time, so you should be very careful here. Given charge is negative. So charge is negative means see what happens. Electric field is along z axis. If charge is negative, electric force will be along negative x axis. Sorry, along negative z axis. I will write here. So it is given electric field and magnetic field. B bar is B naught K cap. E bar, it is E naught K cap. Both are parallel. Coming to velocity, the only change is now having velocity component along z-axis also. Now we have to focus option B. What happens if charge is negative? Okay. So when you are focusing only z direction, so I am focusing only z direction. This is now z. See what happens. Already we have seen what is answer because of this component. Now coming to your V naught K cap. So velocity is along positive direction V naught. If charge is negative, see charge negative means electric force. It will be opposite to field. So we have learned F bar equal to Q into E bar. If charge is positive, force will be along the field. If charge is negative, force is opposite to field. Okay. So electric field is now along z axis. So electric force will be along negative z axis. Then because of this electric force, speed keep on decreases. means velocity component along the magnetic field keep on decreasing. That means pitch will decrease. After some time, this velocity component along z direction will become zero. Okay. After that, its velocity component along z direction will keep on increases. Means up to some time, pitch will decrease, and after that, pitch will increase continuously. Okay. That means coming to option B. See, it is given helix with a decreasing pitch if charge is negative up to some time. So what happens after that? Pitch will increase. Okay. And option C is cyclode, option D circle. So these are not correct. So correct options are A and B. Okay. Let us see next one. A square coil of HL having n turns carries a current type. It is kept on a smooth horizontal plate. A uniform magnetic field B exists in a direction parallel to an edge. The total mass of the coil is M. What should be the minimum value of B for which the coil will start tipping over? Right? See how to start. Let us make a diagram. There is a square coil. So this is now a square coil placed on. See the question once. Square coil, edge is L. Edge is L. Having n turns. Having n turns carries a current kept on a smooth surface which is horizontal. Uniform field exists parallel to an edge. So field is now, let us take field is now like this. P bar parallel to an edge. Right, total mass is M. What should be the minimum value of P? Total mass is right. So I assume that this board plane is a horizontal and we are seeing this one from the top. Okay. So this is not top view. And let us assume current is now clockwise. Current is clockwise. So this is a P, Q, R, S. Okay. Now see carefully. Because of this current on PQ, there is no force because of the magnetic field. Because we are knowing that magnetic force on a current carrying wire is equal to I into L bar cross B bar. Right? So here between L bar and B bar angle is 0. That's why on PQ no force is acting. On PQ force is 0. In the same way on RS force will be 0 because angle is now 180. Okay. So on these two no force act. Now coming to PS and QR. Focus one's direction of force. Let me take this XY plane. This horizontal plane is now XY plane. Right. Focus direction of force on PS. Direction of force on PS. I into L bar. L bar will be PS. Direction of L bar is direction of current. That is now J cap. So L into J cap. J cap across L bar cross B bar. B is now along positive x-axis. So it is now BI cap. So it is now ILB. J cap cross I cap. J cap cross I cap means it is minus K cap. Means the force acting on this is downwards. Okay. So because of that, nothing happens. Right. And you can guess on QR. On QR, value same ILB, but a force will be K cap. Reason is that direction of current is opposite. Means this is now minus J cap. Then we get here it is K cap. So on QR, force will be upwards, means towards us. Because of that force, this loop will rotate about PS. I am repeating. Because of the force on QR. So this is a QR, okay, not QS. This is a QR. So because of the force on QR, the square loop is having a tendency of rotation about PS. Okay, about PS, it will try to rotate. Now, condition is that minimum value of B for which the coil will start tipping over. That means the coil will rotate. Then see what happens because of this, due to this torque, sorry, due to this force, torque will be I into L into B into L. This is now torque due to this force. If this torque is greater than torque due to gravitational force. So when it is about to rotate about axis PS, because of mg, torque will be, it is mg into L by 2. Okay, so L gets cancelled. And here we are given number of turns, it is N. So we should take here N. Okay, that we have missed here, N turns. That means the force, it is into N. Because one turn means ILB, one more turn, again ILB. So it is into N. Okay, for N turns. That means from this minimum value of B. So B is greater than mg upon 2NIL. Okay, that is now minimum magnetic field. Means if B value equal to this, it is about to topple. If it is greater than this, it will topple. It is tipping over about PS. Right? Let us see next one. Let's see the question given. A charged particle of charge Q mass M is moving with initial velocity V as shown in a uniform magnetic field minus B K cap. The given direction of the field is along negative z direction. So we have to choose now correct options. Velocity of the particle when it comes out of the magnetic field. Time for which particle is in the magnetic field. Distance traveled. I think directly we can say option D is not correct. Let us now cross check the remaining three options. First of all, make the given diagram. So given it is XY plane, and field is only right of this line, and field is into the paper. And this angle is now 30. Right? Let us see how to start. First of all, make a circle to get more clarity. So first we're making circle here. So I'm making now here circle. So this bottommost point that is now origin. So this is now X, and this is now Y axis. Let us take somewhere here. This is now center. Let us draw one line here from center to a point on circumference. Let us draw now this bottommost point and this line. Okay, this point. Then see what we get here. So line joining these 2 points. So now field is right of this line. Okay, field is now in this region. And given this angle, it is now 30. Right? Okay, now see carefully. This is O. Let us take this as A and this as B. You can see OB and BA both are same, equal to R. Right? Now, this total angle is 90, total value. This is 30. So remaining will be 16. This is 60. When this is 60, this angle also 60. Relation is OB and BA both are equal length, R and R. If this is 60, this also 60. That means this angle must be 60, right? Now see carefully at this point A, draw tangent for velocity. Okay. So velocity will be along the tangent. Velocity will be along a tangent. That is now along tangential to the circular path. Draw tangent. This is now direction of velocity while coming outside. Okay. Now draw one line parallel to x-axis. Parallel to x-axis. Okay. Now we can see, since this angle is 60, this total angle is now 60. See carefully. This line, OB line, is normal to x-axis. Okay. And this line is normal to velocity. So between the normals, the same angle, it is 60. That means velocity will be V cos 60 I cap, okay, plus V sin 60 J cap. See carefully. V cos 60 I cap, V sin 60 J cap. That is velocity, right? And see by what angle this particle is now rotating. It is through 60. That means we can see options here. How much time it is inside the field, and that is equal to time equal to theta into theta value how much? 60. That is a pi by 3. So pi by 3 into m by bq. This is a time spent inside, because we have learned that to complete one revolution, we have to write in this place 2 pi. It is now 60. That's why it is only pi by 3. Okay. So distance traveled. Distance traveled means we have to focus now arc length. Arc length means it is O2A, right? Arc length for OA. That is now that length equal to r value, mv by bq. So distance traveled, that is equal to r theta. Theta value how much? Pi by 3. So pi by 3 into mv by bq. This is now distance covered. Okay. And from this diagram directly we can say it will definitely come out of the field. So option D not correct. So option C, pi by 3 mv by bq, it is matching. Distance travel, time spent, pi by 3 into m by bq, right? So correct options are B and C. Okay.